In today's lecture, we are going to discuss about the types of processes. There are so many types of processes in the thermodynamics. There are isobaric process, isochoric process, isothermal process, adiabatic process, polytropic process, reversible process, irreversible process, cyclic process. Okay, we have to discuss all these processes one by one. So, welcome back to our basic first year class. In last lecture, we discussed about the extensive and intensive properties, macroscopic property, state of a system, types of a system, open system, closed system, isolated system, and basic concept of thermodynamics. So, in today's lecture, we are going to discuss some types of processes. Let us start with first type, that is isothermal process. Isothermal process. When a system changes from one state to the another state, when a system changes from one state to the another state, during this the temperature remains same or remains constant, then the system is called as, or the process is called as isothermal process. When a system changes from one state to the another state, during this the temperature remains constant, that process is called as isothermal process. There are two types of possibilities arises in isothermal process. One is isothermal expansion and another is isothermal compression. Isothermal expansion and isothermal compression. In isothermal expansion, work is done by the system. We can see in this diagram. In isothermal expansion, work is done by the system. During the expansion, the system absorbs the heat from the surrounding. That system absorbs the heat from the surrounding in isothermal expansion. In isothermal expansion, temperature only remains same when a system absorbs heat from outside, but the system expands among itself, then the temperature definitely lower at final state. So, we are going to use the source for heat absorption. We are going to use a source for the heat absorption, because we have to maintain a constant temperature. That is why, because this process is nothing but isothermal process in which temperature remains constant. For maintaining temperature, we are going to introduce a source to absorb that heat. In case of isothermal compression, work is done on the system by the surrounding. In this case, heat is ejected to the surrounding. Again, in isothermal compression, work is done on the system, is converted into the heat, and ultimately, in order to maintain the temperature constant, heat is ejected to the surrounding. This isothermal expansion and compression both are vice versa. In case of expansion, work is done by the system. In case of compression, work is done on the system. Okay. In isothermal expansion, temperature only remains same when a system absorbs heat from the outside, That is why in isothermal expansion, source is introduced to absorb that heat and to maintain a temperature constant. In isothermal expansion, work is done on the system is converted into the heat and ultimately to maintain the temperature constant, heat is ejected to the surrounding. So, in this case work is done by the surrounding on the system, work is done by the surrounding on the system. That is the main difference between the isothermal expansion and compression. Okay. So, next one, adiabatic process. Actually, there is no complete adiabatic process is possible, because there is no exchange of heat between system and surrounding. So, let us understand what is by adiabatic process. The system which neither exchange heat with surrounding, then system is called as adiabatic. The system which neither exchange heat with the surrounding, then the system is called as adiabatic. In adiabatic process, there are two possibilities are there. One is adiabatic compression and second one is adiabatic expansion. Adiabatic compression and adiabatic expansion. In adiabatic expansion, the system expand at the expense of internal energy, because there is no other possible source of energy. That is why the change in energy decreases, delta E decreases, final temperature get down in adiabatic expansion process. In adiabatic compression, the system work is done by the surrounding. So, heat up the molecules of the system, there is no possible of heat rejection to the given temperature. Both are exactly opposite. In second case, the change in energy increases and the final temperature is higher. That is why T2 is greater than T1 in case of adiabatic compression. Adiabatic compression, as we see in second diagram. In adiabatic expansion, pressure, initial pressure is greater than Pex. The energy difference between E2 and E1 is negative, that is why change in internal energy is decreases and the temperature of T1 is greater than T2. In adiabatic compression, T2 is greater than T1 and delta E is positive, delta E is positive. This is the main difference between the adiabatic expansion and compression. Okay. So, next one, reversible process. Actually, it is a hypothetical and a imaginary process. practically it is not possible, because it is a ideal and imaginary work. Because the opposing force and driving force are comparable, so work done is maximum. So work done is maximum. It takes infinite time to complete and infinite step to complete this process. It takes infinite time to complete and infinite step to complete. It takes place infinite slowly in such a manner the system remains at equilibrium at each and every step. So a lot of steps to work done take place. When you combined all the steps, then we get total work done. It is reverse at each and every step. If we see this diagram, pressure versus volume, the area of A under curve ABCD, the total work done in expansion from volume V1 to the V2. This left side graph shows work done in reversible process. So in next, irreversible process. Irreversible processes are the very rapid process. There is a very large difference between the opposing and driving force. Irreversible process are also called natural process and a spontaneous process. Either natural and spontaneous process. If we see the graph between the pressure versus volume, it is not a reversible. It only reverse when total work done is equal to Pex into V2 minus V1. Any doubt in this? If you have any doubt, you can ask me in comment section. The remaining part of this type of processes we will discuss in next lecture. After that, thank you.